This is the first pattern. Actually, we analyzed it in the classroom, and quite a few got the pattern within a couple of minutes. And that's going to happen with the uh, young students. Well, the way I look at the pattern is this. I'm looking at the first pattern, which is 1 squared plus 1 times 2. So step number plus step number times 2. The second one is if I square the step number, which is 2 squared, plus step number times 2. For the third one, if I square 3 squared plus 3 times 2, and obviously I think it'll be 4 times 2. Right, so 16 plus 4 times 2, that gives you 8 plus, that'll give you the fourth one. So from there, if I make an assumption, the pattern number is n, and the small squares are s, the general rule will be number of small squares equals step number squared plus step number times 2. Right. Usual process is to make quick tables. 1, 2, 3, 4. These are the step numbers. And the number of small squares altogether. The first one is 3. The second one has 8. Third one has 5 times 3 is 15. That one will be 4 times 6 is 24, and so on. Now, if we go for first difference, just like the linear pattern, this is the difference is 8 minus 3 is 5, 7, and 9. So I can guess now that it is not linear. Why? Because the first difference does not stay same. It keeps changing. And it keeps changing in a definite pattern. And I'm going to call it second difference. It's 2 and 2, right? And when second difference stays constant, that gets you the quadratic pattern. Yes, it is nonlinear, but it is a very specific nonlinear quadratic pattern. So I have shown you two methods. This is possibly understood by most of the people, and this is more sort of mathematical. We call it a discrete difference. And Why would you go for the discrete difference? Because sometimes when the pattern becomes really complex, it'll be very difficult to have look at the pattern and make a gut sort of feeling deduction. It's not possible sometimes. That's the time this discrete difference method will always work. I sometimes call it a third method. Let's look at the multiplication table. 1 times 3, 2 times 4, 3 times 5, 4 times 6. It's not a separate method, but if we look at the two patterns, these are the two patterns, the pattern 1, pattern 2, and the pattern 1 is the step number, and you are timesing step number plus 2. So this is step number is 1, and you are timesing 1 plus 2. This one is step number is 2, and you are timesing step number plus 2, and 3 step number plus 2, and thus you can make a guess now. If I times the pattern number by the pattern number plus 2, that will give you the equation or the rule. So the rule could be also written as and now you got to prove these two are equivalent, and that's when our skill of factorizing and expanding comes in. We'll talk about that in details tomorrow. Thank you for watching.